Section 4.2, trigonometric functions in the unit circle. Make sure you're paying attention to the special directions for the homework in problems 5 through 15. The only thing you need to do is draw reference triangles in the correct quadrants, label all sides and the reference angle, and that is all that you need to do for those problems, so disregard any other things that are in the directions. Okay, the first 8 identities of the identities that you will need to know for the next 2 chapters are the reciprocal and the quotient identities. Remember, our simple right triangle trigonometry gives us the relationship between the 3 basic trigonometric functions, sine, cosine, tangent, and the sides that they relate in a right triangle. So katoa, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. When we're talking about our reciprocal identities, sine is the reciprocal of cosecant. So sine is equal to 1 over cosecant. When we take 1 over something, that is the same as taking the reciprocal of it. If sine is the reciprocal of cosecant, that means that cosecant then also has to be the reciprocal of sine. Cosine is the reciprocal of secant, which means then that secant is the reciprocal of sine, or of cosine. Now, you're going to want to remember some tricks to help you remember these so that you're not just straight memorizing all of these identities. For the reciprocal identities, if you can remember that the cosine, and cosecant do not go together, then you should know those 4 identities without a problem. So in other words, then sine has to be matched up with cosecant, and cosine has to be matched up with secant since the cos do not go together. Tangent as a reciprocal identity is paired with cotangent. So tangent is 1 over cotangent, which means cotangent is 1 over tangent. So there's your 6 reciprocal identities. Those will be the first 6 questions on every single identity quiz that you take over the next 2 chapters. The quotient identities, quotient meaning division, is a division of the 2 trig functions. Tangent is opposite over adjacent. That can help you remember what your quotient identities are. Tangent being opposite over adjacent, well, opposite is dealing with sine, adjacent is dealing with cosine. So tangent, if it's opposite, which is sine, over adjacent, which is cosine. And now if we know that cotangent is simply the reciprocal of tangent, instead of sine over cosine, we're going to have cosine over sine. So there's your first 8 identities. Again, those will be quizzed often throughout the next 2 chapters. 2 triangles that you must know to be successful in this chapter are 30, 60, 90 right triangle and our 45, 45, 90 right triangle. Pi over 6 is the same as 30 degrees. Pi over 3 is the same as 60 degrees. Remember, pi radians is 180, so 180 over 6 is 30, 180 over 3 is 60. 30, 60, 90 triangle, you must know this relationship. 1 to root 3 to 2. You have to be able to draw that triangle. You have to know what sides are across from what angles. Knowing your properties of triangles. Always across from the right angle has to be the biggest side, so that's how we know the 2 goes there. Across from the smallest angle has to be the smallest side, which is why always across from 30 is going to be 1. Across from 60 is the side length in between, since 60 is between 30 and 90. In this case, root 3, which is 1 point something, is between 1 and 2. So you should not get mixed up about what goes where if you remember your standard properties of a triangle. Smallest angle is across from smallest side, biggest angle across from biggest side. 45, 45, 90 triangle. Pi over 4 radians is the same as 45 degrees. So these 2 angles are both pi over 4. Sides are 1 to 1 to root 2 in a 45, 45, 90 triangle. You must know those 2 triangles to do everything that we are going to be doing in this chapter. Find all 6 trigonometric functions for t equals pi over 3. For every single time that you are asked to write all 6 trig functions or evaluate a specific trig function, you must have a reference triangle. If you do not have a reference triangle, you will not receive full credit on those problems. Once you have your reference triangle drawn, it's a matter of using your right triangle trigonometry, which all of you should be hopefully very comfortable with, using your acronym SOHCAHTOA. In this case, pi over 3. Remember from the first section of this chapter, our initial side or starting side for our triangle is always along the positive x-axis here. We're rotating pi over 3 radians. Pi over 3, if you don't know, and you need to get to know, is 60 degrees. If we rotate 60 degrees, we're going to stop in quadrant 1. Here's common mistake number 1 that will be made for these problems. To finish your reference triangle now, your third side of the triangle is always going to be drawn to the x-axis. It will never be drawn to the y-axis. So don't draw something over here ever connecting it to the y-axis. That will never happen. Third side is always drawn down to the x-axis here. There's your right triangle. We know that we have rotated pi over 3 radians, so this angle has to be pi over 6. Once you do that, go ahead and label your sides. 1, square root of 3, and 2. We know this side's 1 because it's across from pi over 6 or 30 degrees. This is your reference triangle. And again, for those problems that it said draw a reference triangle with sides and angles, that's all you would have to do. You're done. Stop there for those problems 5 through 15. For this one, now we need to find all 6 functions. So we need to find sine of pi over 3, cosine of pi over 3, tangent of pi over 3. To do that, use what you have drawn in your reference triangle. Use your right triangle properties. Sine, opposite over hypotenuse, root 3 over 2. Cosine, adjacent over hypotenuse, is 1/2. Tangent, opposite over adjacent, root 3 over 1, which is just root 3. Reciprocal identities. Cosecant, secant, and cotangent. Cosecant is the reciprocal of sine, so that's going to be 2 over root 3, or 2 root 3 over 3 when we rationalize. Secant is the reciprocal of cosine. If cosine is 1/2, then secant has to be 2. And cotangent is the reciprocal of tangent, so that's 1 over root 3. We get root 3 over 3. Find all 6 trigonometric functions for 3 pi over 4. Start on your initial side. We're going to rotate 3 pi over 4 radians, which takes us into quadrant 2. There's our terminal side. Third side is always drawn here to the x-axis, don't forget. How do I know that 3 pi over 4 stops right there? Well, we know if we go up to here that that's pi over 2. But with a denominator of 4, pi over 2 is 2 pi over 4. So I know I need to go farther because I need to go 3 pi over 4. If I rotate all the way to here, that's 180 degrees or pi radians, which with the denominator of 4 is 4 pi over 4. 3 pi over 4 is between those two values, so we end up right here. How much farther do we need to go? So what's that angle? That's got to then be pi over 4. Label your sides. Here's common mistake number 2. Remember the first mistake I'm going to see. So there's going to be some of you that want to draw that third side to the y-axis instead of x-axis. Second common mistake is when you label the sides, you are not going to take into account what quadrant you are in. So we know that this is 1, 1, and root 2. But when I go to the left here for this bottom side, that has to be -1. So think about where you're at in the coordinate plane. That's +1. Hypotenuse is always positive. That's going to be root 2. Once this picture is drawn, You've done the toughest stuff. Now go ahead and list all 6 functions. Sine of 3 pi over 4, cosine of 3 pi over 4, tangent of 3 pi over 4. Let's find those basic ones first. Sine, opposite over hypotenuse, 1 over root 2. Rationalize. Cosine of 3 pi over 4, adjacent over hypotenuse, negative 1 over root 2. Negative root 2 over 2. Tangent, opposite over adjacent, negative 1. Reciprocal identities. Cosecant, secant, and cotangent. Cosecant, reciprocal of sine. Now, when you do these, look at what you did before you rationalize. So right here, sine was 1 over root 2. Take the reciprocal of that. It's just root 2 over 1 or root 2. Cosine, look at this one. We get negative root 2 when we take the reciprocal. Tangent, or cotangent, is the reciprocal of tangent, so that's still going to be negative 1. Negative pi over 6. This time I'm rotating in the negative direction. I'm going down pi over 6. So we know this angle here is pi over 6. It's a 30, 60, 90 triangle, so that's pi over 3. When you label your sides, make sure you take into account the quadrants that you are in. This has to be root 3, negative 1, and 2. Sine, cosine, and tangent. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent, negative 1 over root 3, and rationalize. Three reciprocal functions: cosecant, secant, and cotangent. Cosecant, reciprocal of sine is negative 1/2. Sorry, reciprocal of sine, negative 2. Secant, reciprocal of cosine, 2 over root 3. Rationalize that. Cotangent, reciprocal of tangent, is just negative root 3. Now, notice that if you make that second common mistake that I said I'm going to see, and you forget to put this side here as negative 1, you're going to have 4 sign errors, which means you're going to lose 4 out of 6 points because you're going to identify 4 of those 6 functions wrong every single time that you forget that negative sign. So make sure that you are paying attention to the quadrant you are working in, and you label the sides accordingly. Negative 11 pi over 3. If you know your standard angles, pi over 3 is 60 degrees, so I'm taking negative 11 times 60. That means I'm rotating negative 660 degrees. So when I do that, I'm rotating negative. I go once all the way around. There's negative 360. I need to go 300 degrees more. There's 90 more, 180 more, 270 more, 30 more takes us into quadrant 1. So if this angle here was 30, that means this angle here has to be 60 or pi over 3. Label the sides. Across from pi over 6 is 1. Across from pi over 3 is root 3. Hypotenuse is 2. There's your reference triangle with everything labeled. And now find the 6 functions. Sine opposite over hypotenuse is root 3 over 2. Cosine adjacent over hypotenuse, 1/2. Tangent opposite over adjacent is root 3. Reciprocal functions. Cosecant. Secant. Cotangent. Cosecant. Reciprocal of sine is going to be 2 over root 3. Rationalize. Secant is the reciprocal of cosine. That's just 2. Cotangent, reciprocal of tangent, is going to be 1 over root 3, and rationalize. Okay, the last thing in this section are quadrantal angles. Quadrantal angles is an angle whose terminal side lies either on the x-axis or y-axis. Now, I talked about anytime you're evaluating the functions that you must have a reference triangle. Well, if it's a quadrantal angle, you're only going to have what we're going to call a reference point. For quadrantal angles, we're talking about when we rotate and we end up at one of those 4 spots. In other words, if I rotate 0 degrees or 360 degrees, I end up right here. That, then, all of these points lie exactly 1 unit from our origin. So this point would be at the ordered pair 1, 0. If I rotate 90 degrees, then I end up right here. Now that point then is going to be at 0, 1. Rotate 180 degrees, I end up right here. That point's going to be at negative 1, 0. And I rotate 270, I end up down here. And that point is going to be at 0, negative 1. From this, ordered pairs, remember when we have an ordered pair, that's an x value and a y value. The only 2 trigonometric functions that you can get directly from our reference point here are cosine and sine. One of the coordinates is going to be cosine, one is going to be sine. How can you keep track which is which? It goes in alphabetical order, just like your ordered pair goes in alphabetical order. So x is going to be your cosine value, y is going to be your sine value. So let's look at a couple of these. Let's say that we're talking about 90 degrees. So if we were talking about 90 degrees, I would have this reference point right here. I would label this ordered pair 0, 1, and that's all that I would have for a reference point. Now, if we wanted to find sine of 90, cosine 90, tangent 90, cosecant, secant, and cotangent. The only 2 of those 6 that I can find directly are sine and cosine. Sine is the y coordinate, so sine is going to be 1. Cosine is the x coordinate, cosine is going to be 0. The other 4 functions now, you have to know your reciprocal and quotient identities in order to find them. Tangent as a quotient identity we know is sine over cosine. So this is 1 over 0, 1 divided by 0 is undefined. Cosecant is the reciprocal of sine. 1 over 1 is just 1. Secant is the reciprocal of cosine. So that's going to be 1 over 0, which is undefined. Cotangent, reciprocal of tangent, is going to be 0 over 1, which is just 0. So there are the 6 functions for a 90-degree angle. Let's do one more. Let's look at a 180-degree angle. So if I rotate 180 degrees, I end up at that ordered pair right there. Sine, cosine, tangent. Let's find those 3 first. Sine is the y coordinate. So the sine of 180 is going to be 0. Cosine is the x coordinate, negative 1. Those 2 should be easy. Now the other 4 then come from knowing your identities. Tangent of 180, opposite over adjacent is tangent. Remember, opposite is sine, adjacent is cosine. So in this case, our quotient identity, sine over cosine, is 0 over -1, which is 0. Cosecant, reciprocal of sine, 1 over 0, which is undefined. Secant of 180, reciprocal of cosine, -1. Cotangent of 180, -1 over 0, which is undefined. So for quadrantal angles, remember you will only have an ordered pair in your coordinate plane. You will not have a reference triangle. You will simply label the reference point and then find your 6 trig functions from that point.